And welcome back, students, to our next lesson for review here. We're going to jump right in and talk about branching statements. So, if you recall branching statements, Java has two different types. The first is if-else, and the other kind is switch statements. Now, both of these types test pretty much to see if a condition is true, and then execute the corresponding code, if that condition has been met. So let's first remind ourselves about if-else. So Java will always require at least an if statement. So if a condition is true, then do some code. An else statement will act as a catch-all. Now they're not always required, and they don't require any conditions. So you have to have an if. You can't just put else, you have to have an if first. All right, and you'll notice with Java, with our if, we have parentheses here that contain some kind of conditional. With else, there's no parentheses there, and it doesn't contain any conditional. All right, so pretty much just acts as a catch-all. So you have your if, then you have your else, and of course the else will be your catch-all here to do whatever corresponding other code you have. Now there's also else ifs, which is if you want to test more than two conditions, because technically with an if else you can test two conditions. You can test, condition one with the if, and then whatever else happens with the else. Now you can use else if to test other conditions. All right, so if I want to test something specific, so let's say I want to test if x is greater than 5, that's an if. But I also want to test to see if x is, let's say, equal to 0. I can use an else if that. So I can say like, if x is greater than 5, do this. Else if x equals 0, do something else. Else x is a catch-all. So one thing to remember about else's is that they will also come after an if. All right, it always has to go in the order. If first, then else if. So you can have multiple else ifs. So you can have an if and then followed by an else if, followed by an else if, followed by another else if, so on and so forth. Now the thing to remember is that else may or may not follow the final else if. Now that doesn't mean else is always going to be at the end, no matter what. But you may not have that else in there. All right, so else does have to go to the end, but again, it's not going to be, necessarily required. You can have just if and else ifs. So if a condition is true, do some code. Else if a condition is true, do some other code. All right, we also have compound statements. Sometimes we need to test multiple conditions at once. So you can use either and or conjunctions in order to test those two conditions. Now, remember, when you have an and compound statement, both your conditions have to be true in order for it to be true. Right? Otherwise, it's false. So if I'm testing, let's say x is less than 3 and x is greater than 5. Well, if one of those numbers is not true, obviously you can't have, in that scenario, you can't have them both be true. So the answer is going to come out false every time. Right? Also, remember that with an or statement, both conditions have to be false in order to be false. Otherwise, it's true, because with an or, if at least one of those is true, then you have a true. So compound statements, of course, can be used in both if and else if statements. So if condition 1 is true and condition 2 is true, do some code. And you can just easily also change that from and to an or. All right, comparison operators, because obviously we need to remind ourselves of all the different things that we can do. So obviously we have our less than symbol and our greater than symbol. Right, those are found directly on our keyboard. Now we also have, of course, less than or equal to or greater than or equal to. Remember, we don't have a corresponding symbol that matches what would be normally like we do in math. So we follow that up with the equal sign. Then we have equal to. Remember, when we're doing comparison, it has to be two equal signs. We can't just do one, because if we do one equal sign, that tells Java set the value of something equal to something else. When we do an equal equal, that means compare to see if these two are equal. So big important there. Then we have not equal to. This tests to see if something obviously is not equal to another thing. This again is cell comparison. We have our double ampersand to represent and. We have the two vertical bars to represent or. Remember, that's usually found right above enter by holding down the shift key. And if we want to compare something that is not a primitive type, we can use the equals method in order to compare two objects. One thing I want to remind you about, though, is don't use equals equals unless you're checking to see, oh, and I said we used the wrong two, to see if they contain the same reference value in memory. All right, switch statements. Java also has the ability to use switch statements instead of if else. Java will contain some switch value that is a variable in order to determine which switch to use. Now, each case is switch to be ended with a break, and then the final case is always going to be labeled as default. So int value equals 3, final number. Switch value, and we're going to use case 1, final number equals value, break. Default, final number equals 0, break. In this case, because value was set to 3, it would look at this first case. Well, case is not 1, so it's going to go to the default. Right? This is kind of like the our if else's. This is kind of like the else of a switch statement. Right? It acts as the kind of the catch-all. Now, technically, you can go without defaults in there, but the compiler might complain about it, so we usually leave default in here. Unlike with if else, we don't need else in here. With switch statements, we have to have our default in here. All right, and that's going to kind of wrap it up there, folks. And I guess we will see you next time.